Alright class, we've got several things that we have to be able to do with undetermined coefficients and with second order non-homogeneous differential equations. We need to be able to find a corrected form for yp, so we'll talk about that. We'll need to find a general solution, so we'll do that. We'll find the solution for yp as well in addition to the general solution, and then we're going to solve an IVP. Okay, so all four of those things are things that we're going to do in this video. So this one's going to pack a lot in. Alright, so something I didn't tell you with method of undetermined coefficients part 1, it is necessary for you to get the homogeneous solution in order to get the correct yp. So our homogeneous equation is y double prime plus 4y prime plus 4y equals 0. So I just took the left hand side, set it equal to 0, and then we write our characteristic equation. Okay, this one's going to have a double root, so it factors into r minus 2 squared equal to 0. So r equals 2, and remember dr stands for double root. Alright, so let's write down our homogeneous solution. So yh, h for homogeneous, this is c1 e to the 2t plus c2t e to the 2t. Okay, so let's see how that plays in. So our guess for yp, looking at 12 e to the 2t, would be that y equals a e to the 2t. Okay, so here's the part that I haven't told you about that. Okay, yp must be linearly independent from y1 and y2, or else yp is just a homogeneous solution. And one of the things I've loved to do in the past to torture my students is to start off with this guess and not tell them all of this information, to have them figure out what a is. And what happens is they substitute, they find yp prime and yp double prime, and they end up getting 0. They end up getting 12 e to the 2t equals 0. That's because a e to the 2t is the same thing as c1 e to the 2t, which is a homogeneous solution, which it makes sense that when you substitute it in, you get 0. Alright, so how do we fix this? Well, when we've, just looking at this example, you had one root, and to make something linearly independent, you multiplied it by t. So same thing applies to yp. So we're going to multiply by t. I'm leaving a little bit of room because something special is going to happen here. So at e to the 2t is not linearly independent from c2 t e to the 2t. So we actually, in this case, have to multiply by t squared. That's only ever going to happen when you have a repeated root, and you also have that as your right-hand side. Okay? So this is the correct form of yp. Alright, so when someone asks you, what's the form of yp, this is what they're expecting you to give as an answer, not asking you to solve anything, just expecting you to give this. And that's going to happen on the homework, so pay attention to that. Alright, yp prime equals, I'm just going to do the product rule, so 2at e to the 2t, and then the derivative of e to the 2t is 2, so that's going to be 2at squared e to the 2t. Not too bad. Yp double prime though, messy. So we're going to have product rule twice, so we're going to have 4 terms. So 2a e to the 2t, and then the derivative of e to the 2t is 2, so 4at e to the 2t, and then over here, derivative of t squared is going to be 2t, so plus 4at e to the 2t, and then the derivative of e to the 2t is 2 e to the 2t, so plus 4at squared e to the 2t. Okay, now there's some couple terms you can combine there. Those you can make them into 8at e to the 2t. It's a tongue twister. Alright, so what do we do from here? Well, we substitute that. Remember how we handle this. We substitute in the differential equation, we set it equal to the right hand side, and we make it work. Now you may be thinking to yourself, this may be a problem, because on my differential equation I don't see any t e to the 2t terms or t squared e to the 2t terms. on the right-hand side. So let's see what happens with that. All right, so I'm just going to simplify this as I go. So this is going to be 2a e to the 2t plus 8a t e to the 2t plus 4a t squared e to the 2t. All of that is yp double prime. So that's minus 4 times 2a t e to the 2t plus 2a t squared e to the 2t. So that's minus 4 yp prime. And then plus 4a t squared e to the 2t. And that's my 4 yp. Okay, so let's just simplify that. So that's all supposed to equal e to the 12 e to the 2t. So I've got my 2a e to the 2t. Okay, I've got 8at e to the 2t minus 4a times 2a t e to the 2t. Those are going to cancel. I've got 4at squared e to the 2t minus 8at squared e to the 2t plus 4at squared e to the 2t. Those are all going to cancel. And that always happens. Okay, so when you have these repeated parts and you're worried about them, don't. They should cancel off, and we get 2a e to the 2t equals 12 e to the 2t. So 2a equals 12, and a is 6. Okay, so where are we at the moment? Well, at the moment we know our general solution. So our general solution is c1 e to the 2t plus c2 t e to the 2t plus 6 t squared e to the 2t. Okay? Now, we've got an initial condition, an IVP up here, so y of 0 equals 3 and y prime of 0 equals 10, so we're going to need to take a derivative. So let's do that. So yg prime is going to be 2c1 e to the 2t plus c2, I've got product rule here, so e to the 2t plus 2t e to the 2t, and then I've got product rule again. So that's plus 12t e to the 2t plus 12t squared e to the 2t. Okay, that looks really bad, but actually it comes out pretty nice. So when we use the initial condition of y of 0 equals 3, that's going to be pretty nice. So right here in yg, when you plug in 0, that's 0 and that's 0, so all that stuff goes away. So all we have is that 3 equals c1. That was pretty easy. Okay, and y prime is 10 at 0. So let's take a look at this. So 10, what's that going to equal? Well, this part, so 2c1, okay, and then this part, so e to the 0 is 1, so it's going to be plus c2, and then everything else has a t in it, so everything else is going to be 0 at 0. c1 is 3, so that's 6, so when we subtract 6 from 10, we're going to get 4, okay, and there we go. And last thing, I'll write down the final solution. I have one more remark to make about it. So y equals 3 e to the 2t plus 4t e to the 2t plus 6t squared e to the 2t. Okay, so something that is really, really important when you're doing IVPs. And this is something I try to stress every year, but some people just don't listen or pay attention to it. Okay, so notice that in order to find C1 and C2, we can't just take the homogeneous solution here and plug our initial conditions in. We actually have to have the entire general solution for the non-homogeneous IVP. So we couldn't substitute the initial conditions in until we got to this part right here. That's extremely important, and if you don't do that, if you find the initial conditions based on, if you find C1 and C2 based on the initial conditions for the homogeneous equation, you're wrong. Okay? So make sure that you use the entire general solution if you're going to find, if you're going to use the initial conditions and solve the IVP. All right, that's it for this one.